Okay, so next here we're going to do the worksheet of the starter, the pre-worksheet. So in this we're going to learn the steps in writing chemical formula of compounds. For that, let us take the examples given here. The first one, sodium hydroxide. So in any chemical name, the first part is always the positive radical or the cations, and the second part will be always electronegative radical, okay, like we did in starter. Now from starter we know that sodium ion is, the first step is we do this Na1 plus, so we just write that as it is, Na plus, which means 1 at the top. And in the electronegative we find the hydroxide, so OH1 minus, so hydroxide ion. So we write it like that, step 1. Second step is we look at the valencies, here 1 plus, here 1, and if we can cancel them, we must cancel. But since we know that 1 and 1 can't cancel, we go to the third step, okay? The third step is crisscross the valencies. Crisscross. What do we mean by this crisscross the valencies? For that, the third step, we just write a symbol here, Na, without the valency here, 1 plus. And the symbol for hydroxide here, OH, but without the top number, 1 minus. And crisscross valency means the valency 1 of OH will go to the lower backside of Na, and the valency of 1 plus here, 1 without a sign, okay, of Na will go to the lower backside of OH. But since both are 1, we need not write that. So the formula for sodium hydroxide is NaOH. Similarly, as we learned just now, every chemical formula has the positive and the negative part. So we will find this magnesium ion in the electropositive ion group, which is, as we learned in starter and memorize, Mg2+. And we go and we find the oxide ion in the group of negative electronegative radicals, and we know oxide ion is O2 minus. So we write it as it is, oxide ion here, the notation, and the magnesium ion here, the notation. The second step, as we learned just now, is we check the valencies to cancel them. Now we know this valency here 2 plus and here 2 minus can cancel, like 2 ones are 2. So with the same number we used here, here also 2 ones are 2. We reduce it to the lowest possible, which is now 1. After that we go to the third step, which is the crisscrossing of the valency. As we learned here, for that we just write a symbol without the top number here, 1 plus, which remains. And here O without the 1 minus. And since both here are 1, we need not shift the number. It will be simply MgO, the formula of magnesium oxide. Likewise, here ferric ion we know is Fe3+, and oxide ion is O2 minus. Now second step, we check the valencies to cancel. But since 2 and 3 can't cancel, we go to third step, which is crisscrossing valency, which is just right here Fe the same without a 3 plus, write a O without a 2 minus. And as we learned earlier, crisscrossing valency means exchanging the valencies. So 2 that belongs to O will go to the lower backside of Fe, and 3 that belongs to Fe will go to the lower backside of O. That is what we mean by crisscrossing the valency. Basically means the valencies exchange. So the formula will be Fe2O3 for ferric oxide. I think we can go slightly faster now since you're understanding. Here's sodium ion, the positive is Na1 plus. And you would recall from your starter that hydrogen carbonate is the negative ion HCO3 1 minus. Now, since the valencies are both 1, we can't cancel. So we crisscross the valencies. Write the Na without a 1 plus, HCO3 without a 1 minus. And since both are 1, we need not write that. So the formula of sodium hydrogen carbonate is NaHCO3. Next, listen carefully to this so you don't get confused. The positive here, silver ion, we know from our starter is Ag1 plus. A nitrate ion is a negative radical, electronegative to be specific, NO3, 1 minus. Now since both valencies are here 1 plus and here 1 minus, remember 3 is not at the top, so it's not a valency. So we go to crisscross valency, which means we write the Ag without the 1 plus, and we write the NO3 without writing the 1 minus. Remember 3 is not at the top, so we have to write, okay? Since both valencies are 1, we need not shift that number. The formula is AgNO3, which means 1 here will go to the lower backside of Ag, 1 here at the top of Ag will go to the lower backside of NO, which we didn't write because both are 1, the valency. Okay, the next one here, calcium ion we know is Ca2 plus, and carbonate ion is the negative 1, which is CO3, 2 minus. Now we see here both valencies are 2, so we can cancel them as 2 ones are 2, 2 ones are 2. So once the valency is reduced to the smallest possible number, which is 1 and 1 in this case, just write the symbol without the plus at the top, write the symbol CO3 without the 1 minus. Since both valencies are 1, the formula of calcium carbonate will turn out to be CaCO3. Okay, next one here, barium ion we know is Ba2 plus. Chloride ion is Cl1 minus. Valency here 2 and here 1 minus can cancel. So we go to crisscrossing the valencies by writing the Ba without a 2 plus, Cl without a 1 minus. 1 need not be shifted, but this 2 at the top of Ba will go to the lower backside of Cl, but there will be no bracket because Cl is a simple ion, meaning it contains only one type of atom. Cl represents only one type of atom, that is chlorine atom. So in such cases, we don't put bracket, okay? So the formula will be BaCl and 2 at the bottom of Cl, BaCl2. Listen to the next one carefully and compare with this BaCl2 to understand the difference between 7 and 8, okay? Magnesium ion, Mg2 plus, hydroxide ion, OH, 1 minus. Now we know 2 and 1 can cancel. So we go to third step directly, which is crisscrossing valency, for which we just write the same symbol without a 2 plus. OH we write without a 1 minus. This one will go to the lower backside of Mg, but we need not write because it's only 1. This 2 that belongs to Mg will now go to the lower backside of OH only after a bracket at the bottom of OH, because OH is a compound ion, meaning contains more than one type of atom. Here you see hydroxide contains oxygen and hydrogen atom. So when an ion contains more than one type of atom, it's called a compound ion. So hydroxide is a compound ion. Therefore, we had to put the bracket here. Here Cl we didn't put because Cl is not a compound ion, simple, because it contains only one type of atom, chlorine atom Cl. Okay, so the formula of magnesium hydroxide is MgOH whole thing 2. So that is the difference between simple and compound ion, how we do the formula. Okay, next is calcium ion, Ca2 plus, phosphate ion, PO4, 3 minus, we know that. Now this valency 2 and 3 can cancel. So we just go to the third step, crisscross the valency, which means we write the Ca without a 2 plus. We write this phosphate symbol PO4 without the top number 3 minus. And then this 3 that belongs to PO4 will go to the lower backside of Ca without a bracket. Because Ca is a simple ion that contains only one type of atom, that is calcium atom. Even though it has 2 letters, this symbolizes only one type of atom, calcium ion. So it's a simple ion, so we don't put bracket in cases of simple ions. Okay. But when you shift this 2 that belongs to Ca to the lower backside of PO4, we must put a bracket because phosphate ion is a, then only bring down 2 because phosphate ion is a compound ion containing 2 types of atoms, as you can see here. What are they? Yes, phosphorus and oxygen. Ca is only calcium atom, but PO4 means containing phosphorus and oxygen atoms. So more than one type of atom, and the number you're bringing down is bigger than 1, then we must put bracket. If it's 1, no need to put bracket, but here is 2, you see. Okay. The next one, finally, ammonium ion is NH, we know 4 down at the top, 1 plus. And dichromate ion is Cr2O7 at the top, 2 minus. The next step is check the valencies here, 1 plus and here 2 minus. They can't cancel, so we just go to third step. Just write the symbol NH4 without a 1 plus. Write the Cr2O7, same as this, without a 2 minus. This 2 that belongs to Cr2O7 will go to the lower backside of NH4 only after a bracket, because ammonium ion is a compound ion containing 2 types of atom, you see here, nitrogen and hydrogen, and it contains even more than total number of atoms, 4 hydrogen atom here, 4 hydrogen atom and 1 nitrogen, so 5. So we need to put a bracket. Then this 1 need not be shifted. So the formula of ammonium dichromate is NH4 whole thing 2, then Cr2O7. So these are the 3 steps we follow when we write the chemical formula from the given chemical name. Okay. Now once you finish this, you go now and then you memorize the starter again thoroughly. Okay, thoroughly the starter, then go and do worksheet 1. Okay, go and do worksheet 1, which is the instructions are written on the worksheet 1 itself. Okay,